Oh, you're here. Come here. Now, there are already some fantastic tutorials out there showing you how to build one of these. This is not one of them. This is the tutorial that I wish I had when I built mine. We're starting from zero, downloading the files, 3D printing them, wiring, soldering, all the way to having WLED running up on your wall, making your setup look like a spaceship. And yes, I'm going to cover the stuff that nobody else does, including the weird filament problem that I ran into, which means I had to actually open up Fusion 360 and fix the model in CAD myself. We'll get to that. Let's build. Alright, so before we start printing anything, we need to get our hands on the actual files. Head over to Andy's printable account, link is down in the description, and we are looking for the Duality HexGrid. Now, since I built mine, Andy has actually updated the design and added what he calls the nested HexGrid. And this is a pretty cool upgrade. You see, the original design basically gives you the hexagons themselves, whereas the nested version adds an outer perimeter around the grid. That makes routing your LED strip a lot easier and gives you a little bit more flexibility when you are putting the whole thing together. And don't worry, if you prefer the original design, that's still included as well. Now, when I bought this model, I paid around $19 for it, and at the time of this recording, the price is $23, which now also includes that nested HexGrid version. And honestly speaking, I really don't think you should be afraid to spend a little bit of money on a good quality 3D model. There's obviously a ton of free stuff out there, and I love free models just as much as the next maker, but when you are talking about a project with this many parts, having a well-designed model, proper documentation, as well as updates from the designer can save you a lot of time and frustration. Once you've downloaded everything, you'll end up with a few different folders containing the various files for the project. And before you get too excited and start sending everything straight to the printer, don't. There's one file in here that I really recommend printing first, and that's the Stencil. This might look like just another random file in the download, but it's actually one of the most useful parts of the whole package. You can use it to work out exactly how many segments you're going to need, experiment with the layout, and most importantly, make sure that the whole thing is actually going to fit in the space that you are planning to put it in. Because the last thing you want is to spend hours and a very unhealthy amount of filament printing your entire hex grid only to discover that it doesn't fit in the space that you intended. Now that we got our stencil printed, it's time to plan the actual layout. I'm laying the stencil out on a sheet of paper, keeping two things in mind: the overall dimension of the hex grid itself and the maximum space that I have available on the wall where I'm going to install it. From there, simply draw out your pattern. Now this is where you can play around with the layout and figure out exactly how you want your hexagrid to look before you start printing everything. Once you got your pattern, we're ready for the next step. Calculating exactly how many segments we're going to need, and more importantly, how many connectors. Because you see, in this design we have a two-way connector as well as a three-way connector. Your design might look completely different. You might want a much larger grid, a different shape, or even just a couple of hexagons. But the process is exactly the same. Plan the layout, count your segments and connectors, and then we'll know exactly what we need before we start printing anything. Alright, before we start printing and putting everything together, let's quickly go over what you'll need for this build. I'm keeping things pretty simple because you really don't need a workshop full of fancy equipment to build a hex grid. For the electronic side, you'll need a good pair of wire strippers, a decent soldering iron. You don't need the most fanciest or extremely expensive brand. They'll work just fine, just make sure that the tip is clean. Some solder, I'm using 6040 Rosen core, focus. A screwdriver for obvious reasons. Some flux, and again, you do not need to use this exact same brand. We're just going to use this to put on the pads of the LED strip to make the solder flow easily. I'm also using some tweezers, which are surprisingly handy when you're working with LED strips and those tiny wires. For the mechanical side, you're going to need some M3 screws. I got these awesome M3 flatheads off of Amazon, and they worked perfectly. And one thing I definitely recommend printing is this little handy soldering jig included in the files. Once you download it, you will find it in one of the folders, and it basically lets you place your LED strip with the 3 wires in these perfectly slotted grooves. It just makes soldering much more easier. For wiring, I'm using 22 gauge silicone wire. I also got this off Amazon. Neat little kit, comes with 5 colors. I'm going with black for negative, red for positive, and green for the data. And then Grogu for some moral support. Alright, now that we've got our layout planned and we know how many parts we're going to need, it's time to start printing. But before you hit print on the entire project, there's one thing I would strongly recommend doing first. Print one complete segment first, that is the base and the diffuser. Because there's nothing worse than spending hours, or in this case, potentially days, printing the entire thing only to find out that something doesn't quite work the way you expected. And here is where I hit a wall. You see, I've worked with LED strips and diffusers quite a bit, so I'm very familiar with one of the most frustrating problems you can run into with a project like this, and that is hot spots, dark spots. Those LEDs were shining through the diffuser like tiny little suns trying to burn a hole through my eyeballs. The problem? My white PLA doesn't diffuse light the way the model was designed for. The diffuser was designed around the material that he used when he created it, and unfortunately Hatchbox isn't something I can easily get here in Abu Dhabi. So I opened up Fusion 360 to try and see if I could just thicken the diffuser a little bit. I started by inserting the mesh file of the diffuser itself into Fusion 360 so that we could edit it and make it a solid body. Once the mesh file is in, let me just orient this properly so that we can see what we're doing. Right, now basically this model is just a mesh, which simply means it is a bunch of triangles. We will not be able to modify or change anything on this design just yet. We need to convert it into a solid body. Start by clicking on the model, clicking on mesh, and over here at the top you want to select this button that says generate face groups. Now we have face groups generated, as we can see by the colors here. The next step is to go to modify, convert mesh, and here after selecting your model, be sure to select the operation as parametric and the method as prismatic. If we click on faceted, it's basically going to generate a model with all of these lines, and we don't want that. So click on prismatic, hit OK, and now we have a solid model. I can manipulate any part of this solid model now, but I only want to change this diffuser plate here. So head over to solid, click on this part, press pull, and I just basically added a little bit material, bringing up my total thickness to 1 millimeter. And basically that's just it. We've now just edited this STL file. All we gotta do now is save it as a mesh again, and you are good to go. You see, that looks much better. The hotspots are gone, the light is evenly distributed, and the whole segment now looks less like individual LEDs sitting behind a piece of plastic and more like one solid LED panel. And honestly, this is exactly what I was after. So with our diffuser sorted and our test segment looking exactly the way we wanted, there's only one thing left to do: print everything. Once all the parts are printed, I like to lay everything out before starting the assembly. This makes it much easier to see what you've got, what you don't have, and gives you a chance to make sure you haven't accidentally printed 37 two-way connectors and absolutely nothing else. From here, it's basically a matter of assembling each segment, connecting everything together, and slowly watching the hex grid take shape. And once that last segment is connected, we finally have a hex grid. But we're not done yet, because at this point we've built a really cool looking piece of plastic that doesn't actually do anything. Alright, so now for the electronics part of the build. The Duality HexGrid uses WLED, which is an open source LED control system that can run on an ESP32 microcontroller. I also printed one of these modified segments specifically designed to house the ESP32 neatly inside the hex grid. And you've got a couple of options here. You can build your own controller using something like the ESP32, which is what I'm doing, Or if you don't want to mess around with the electronic side of things, you can use a ready-made WLED controller such as the Glodopto. Now let's talk about the LEDs. For this build, I'm using WS2812B addressable LED strip with 60 LEDs per meter. And that 60 LEDs per meter density is very important. You see, the diffuser is designed around this LED density, and using fewer LEDs can result in more visible gaps, hotspots, and all the stuff we don't like. Each segment uses about 200 millimeters of LED strip, and that number is actually going to be useful. Because you see, now we can work out exactly how much power that this thing is going to need. Now, before we go and connect everything together, there's one calculation we absolutely need to do, and that is calculating our power requirement. The basic formula is power is equals to voltage times current, or P is equals to V times I. For WS2812B LED strip, we can use the manufacturer's or strip specification for the maximum current draw per LED. So let's work through this using our actual build. Alright, so each of our segments are 200 millimeters, and you can physically count the LEDs, which works out to 12 LEDs per segment. So if each LED can draw approximately 60 milliamps at full brightness, that's going to be 12 multiplied by 0.06 amps, which gives us a total current draw of 0.72 amps per segment. Now that we know the full current draw per segment, we can simply multiply that by the total number of segments in our design. In my case, I have 15 segments, and that's going to work out to roughly 10.8 amps. So this is an important calculation because it tells us what size power supply we're going to need. And I would recommend giving yourself some headroom rather than running your power supply right at its maximum rating. Now we just need to give the HexGrid a brain. So let's set up the ESP32, install WLED, and make the final connections. The ESP32 that I'm using is linked in the description, and it's actually the exact board that fits into the space provided in the original Duality HexGrid design. For a fresh installation, head over to install.wled.me. I'll leave a link in the description as well. First, connect your ESP32 to your computer using a micro USB cable. Then, once the board is connected, the installer should detect the available COM ports. Select the COM port belonging to your ESP32 and hit install. That's it. WLED will take care of the installation and flash the firmware directly onto the board. And while that's doing its thing, it's a good time to mention that you don't need to be an electronics expert to do any of this. We're not writing code, we're not programming a controller from scratch. We're basically telling the ESP32, hey buddy, you're in charge of this LEDs now. And once the installation is complete, we've got WLED running on our ESP32. Now, addressable LED strips are actually pretty simple. You've got your positive, negative, and data connections. The important one to pay attention to is the data line, because unlike power, data only travels in one direction. I like to think of it as the lighting pattern flowing through the HexGrid. So if your data starts here, for example, the signal needs to travel up this route, through the strip, and in the direction of the arrows. And once you get to the end of your HexGrid, simply cut a long enough wire to pass through that center segment and complete the last strip. Alright, so here's a quick little guide just to prevent you accidentally burning out your microcontroller. You see, the ESP32 is a low power device, whereas your LED strip is a high current, high power device. That being said, we cannot supply power directly to the LED strip from the microcontroller. You will burn this board out. So instead, this is how we wire it. The positive and negative from your LED strip gets connected directly to your power supply. Please keep in mind that if your LED strip is 5 volts, your power supply also needs to be 5 volts. Duh! The only wire that gets connected directly to your microcontroller from the LED strip will be your data wire. In my case, this is connected to pin number D2, and we can configure this in the WLED app when we set it up later. Then, the ESP32 also operates on 5 volts. So it simply connects 5 volts and ground all the way to your 5 volts and ground on your power supply. That's it. Got it? Cool. Let's get to soldering. For this build, there is quite a bit of soldering involved, but please don't let that put you off. After the first few joints, you'll settle into a rhythm. And before long, you'll be wondering, why have you ever thought it was difficult? And the nice thing about this project is that all of the connections are basically the same. So by the end of the whole thing, you would have accidentally become an expert at soldering. Who knew building cool lights will teach you a new skill? Andy uses 3 colors of 22 gauge silicone wire cut to around 40 millimeters for each connection, and he also adds a 3-pin header to make connecting them easier, but I decided to keep mine a little simpler and just solder the connections directly once the strips were installed in the bases. And here's the trick that makes the whole process much easier. Tin everything first. Tinning basically means to add a little bit of solder on the wires before you actually put them to the joint itself. Tin the ends of your wires and tin the pads of the LED strip. Just make sure to keep your tip clean, and a little flux can definitely help. Please don't go crazy with the solder, you really don't need that much. Once the solder flows, remove the heat and let the joint cool. That's it, you just soldered a wire onto an LED strip. Do that a few dozen more times, and congratulations, you are now an electrician. So we've made it this far. The segments are printed, the wiring is done, WLED is installed, and now there's only one thing left to do: putting this thing up on the wall. I basically drilled 2 holes at the top and used double-sided mounting tape for the bottom so that it doesn't flop around. Once I got the entire hex grid on the wall and positioned where I wanted it to go, it's time for the final piece, the diffusers. And honestly, after seeing all of those individual parts sitting on my desk, now seeing this whole thing finally come together is pretty satisfying. And this is the finished result, but we're not quite done yet. We just need to configure WLED to make this thing glow, baby. Download the WLED app on your phone and open it up. Now is also a good time to power on your hex grid. Once you connect it to your home Wi-Fi, WLED should automatically scan and detect any ESP32 devices that are running WLED. For my case, you can see there are a whole lot of devices, but I'm going to just show you one as an example. Tap on the one that shows up on your screen and head to config. Now we just need to tell WLED a few things about our setup, so let's go to LED preferences. As we scroll down, your first input parameter is going to be maximum PSU current. This is a nice neat little feature where it automatically limits the brightness. Mine is set to 2000 milliamps. Alright, scroll a little bit down. The type of LED strip that I'm using is WS2812B. The current, according to WLED app, is 55 milliamps, so I'm going to select that one. Color order is GRB. I'm going to leave this standard for now and not interfere with it. Now for the length, for my build I have 12 LEDs per segment and a total of 15 segments, so 12 multiplied by 15 is going to give me 180. Next one is the data pin, and if you remember from before, I used GPIO pin number 2. Enter that number, save the settings, and that's it, we're done. Now comes the fun part. Go and play around with the effects, change the colors, adjust the speed, try different palettes, and spend the next hour changing the lighting every 30 seconds because you can't decide which one looks best. And just like that, our hex grid is alive. If you ended up building one of these, and I genuinely hope that some of you do, please drop a comment. Let me know what filament you ran, let me know how many hexagons you went with, and what was your favorite WLED effect. I genuinely enjoy seeing what other people do with this stuff because honestly, most of my future project ideas come from you guys. And if this video actually helped you, you know what to do with the button down there. I'll catch you in the next one.